Yeah, we wouldn't want to do that.
I would be the first person to test alligator.
All right, hot lunch. Raise your hands. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. Take off your hats and coats, please. And get out your homework, please.
Henry, move back to review one day.
The test is on Friday. Who are we missing? Missing Bo. Does Bo eat hot lunch?
Yes.
Yeah. All right, Ash, get your homework out. Get your homework out.
I swear to God, my house is not 10.
Get your homework out, please. All right, good morning, Malachi, Elizabeth.
Good morning.
You missed our chicken video.
An arrow in Monday.
There's two interesting facts. Listen, please. Listen. There's two interesting facts about chicken. That's one of them. At some point during the year, I'll show you the other interesting fact about chickens. But that's something I don't have to show you. You all know that.
I want to get on a chicken video.
You know how chicken nuggets are made?
So one of the interesting facts about it's for birds in general, they have the ability to hold their head in a stable position while their body moves. Like we can't. If you try to hold your head and move your body, your head moves with your body. Chickens, however, can keep their head still while their body literally moves.
There is some people that do it that can't do it.
Well,
Dancers do. Wait,
we can't do it. Human beings.
wait, can you show us the videos of like chickens being like hypnotized to stay still?
That's the second thing.
Can we
All right. Thank you for ruining it for us.
fried chicken?
All right. So yesterday we did that review. You should have it in front of you right now. Put all that stuff away. Now, I'm going to see if Jameson has the correct answer. So I'm going to call them out, and you are going to correct Jameson if he gets it right or wrong. Ready? Here we go. Number 1, Jameson says it's yes.
Yes.
Number 2 is yes. Number 3 is yes. Number 4 is yes. Number 5 is yes. Number 6 is no. Number 7 is yes. Number 8 is no.
No,
Ooh,
that's completely
Jameson.
wrong.
The digit ends in a 4, so it is even. All right, 1 wrong. 9 is no. 10 is no. All right, all the positive factors of 30. Jameson, you left off a few here, I can tell already. Let's see. 30, that would be 1, 2, 5, 6, 15, and 30.
And 3.
I left off 3 and 10, didn't I? Sorry. Number 12, let's see, 15. That would be 1, 3, 5, and 15. All right. 13, 24, lots of them. 2, 3, 4, 6, 8. What am I leaving off? 12, 24. Did I leave anyone off? I think that's it. 1, right. Thank you. Number 14. So 1, 3, 7, 21. Number 15. That would be 1, 5, and 25. Number 16. That would be 1, 2, 3, 6, 9, and 18. Number 17, that will be 1, 2, 4, 5, and 20. 10, left off 10. Number 18, that would be 1, 2, 11, 22. All right, prime factorization. Number 19, that would be 2 times 43. Number 20, that would be, you had 2 times 45. 2's right, but the 45 can be written as 9 times 5. So 2 3 times 3 times 5, or 2 times 3 squared times 5. 50 would be 2 times 5 times 5, or 2 times 5 squared. 82 would be, well, 41's prime, so 2 times 41. Let's see, 88. I'm trying to read your handwriting, Jameson. It looks like you wrote 2 times 2 times 2 times 11. Is that right? Yes, that's right. All right, Parker, get out your homework. 84 would be 2 times 2 times 21. 80. Did you eat the corner of your paperwork here?
Yeah, that's what happened to mine as well. I don't know what happened.
Maybe he's your twin brother. I don't know. Yes.
And it's the same corner.
You were correct. All right, Jameson, you got another one. Let's see. 2 times 2 times 3 times 7. How about that?
Yeah.
Okay. Good catch. Number 25, 80. Well, let's see. That would be 8 times 10. And 8 can be written as 2 times 2 times 2. And 10 can be written as 2 times 5. So let's see. 4 2s and a 5. Is that right? Okay.
Yep.
4 2s and a 5. Number 26, 2 times 2 times 3 times 5.
Yes.
Jameson, you need to work on your prime factorization. You got every one of them wrong in prime factorization. Other than that, it looks okay. All right. Let's see. Today is going to be an easy day. However, in total, just copy down your homework. I'll save the speech so I can copy down your homework. Make sure you're turning in your homework. Parker, lunch or no lunch? Yes? Let me mark him for hot lunch, and then we'll get going here.
Oh, I caught that. Super fast reflex.
Well, you have 4 siblings, so 6 of them. Yes, you do.
We're going to do one of those today, not both.
Can you see the chicken being hypnotized?
Another day. I only have a finite amount of funny stuff that I can show, and I got to parse it out.
Drew a red circle around it, spit on each of the wrong sides.
You just need to draw a line from the face.
Oh yeah, you have that too. Like if you hold the beak down and then draw a line.
Completely, totally hit the line. Other animals, you do it with other animals too.
He spit to each one, and then he slapped each one, and then let go of the chicken, and the chicken was stuck. Like its legs were in the same position.
All right, are you copying down your homework? I know you're talking, but I'm not sure you're copying down your homework. We'd have to, because I would agree that it has, until we actually use it, which we will do next chapter, until we actually use it, it seems like a pretty useless exercise.
It is.
Right. But it's not, because we will be using it in the next chapter. All right, here we go. Okay, hey, Jameson, you talk. Or stop making noise. Greatest common factor. Now, many of you might remember doing this the previous year, and most of the time, you know, math teachers have you do silly things, and they don't really explain why. The reason why we're doing this thing called greatest common factor, and tomorrow we'll do least common multiple, is because we're going to use them in the next chapter when we deal with fractions. When you deal with fractions, when you add or subtract them, or when you reduce the fraction, you're using the skills of greatest common factor, least common multiple. That's the reason why we do this. Now, I will not lie to you and tell you that I'm going to teach you 2 things that are very easily confused. The words that describe them, greatest common factor, least common multiple, they don't really stick with you. They are descriptive. If you pay attention, they are very descriptive. But for most students, they're like, yeah, I get those 2 confused all the time. Well, luckily in my class, you can bring a resource card. So even though I am going to teach you both, occasionally I get students that come to the test, Friday test, and I ask for the LCM, they give me GCF. Or I ask for GCF, they give me LCM. They get them backwards. Please make sure it's on your resource card with an example of what both LCM and GCF are. And that way, when you get to test day, everyone, I mean, I've never had a student that couldn't do this skill, but I've had plenty of students that mix the 2 up. So sometimes in math, we're our own worst enemy, and we ask you to do something that is slightly confusing, and that's the next 2 days. GCF and LCM. They're easy to do, right? But they're definitely easily confused. So today we're going to be doing greatest common factor. We abbreviate greatest common factor GCF. The reason why we do this is we use this for fractions. Greatest common factor is what you use when you reduce fractions. You reduce a fraction by the greatest common factor of the two fractions. Today we're not doing fractions, we're just finding a GCF. That's it, that's the whole class. Okay? So here comes another bad or good thing. There are multiple methods of doing this. I don't know who you had for math teachers before. Maybe they've showed you both techniques, right? I'm going to show you both techniques. Now listen carefully. This would mean you're looking at me, right? I'm going to show you both techniques. Most people gravitate towards the first technique, but if you want to use the second technique, that's fine. The second technique is elegant, it's sweet, it's mathematically very lovely, right? Nobody uses it, right? Everyone uses technique number one, but I will show you both techniques, right? You can choose which one you like. Write this down, please, box one. Today we're going to be doing greatest common factor, and that's the largest factor of two or more numbers. Tonight for homework, I think they have you do the GCF of 3 numbers for a couple of them, but they never have you do it for like 4 numbers, or I think I'm right on that. I think it's just 3 numbers is the max they have you do. Normally, you're looking at 2 numbers. You have 2 fractions. You got to add. You got a fraction. You got to reduce it. So normally you're looking at 1 fraction, right? 1 number that you're trying to find the GCF of. But a fraction is made up of a numerator and denominator, so technically you're looking at 2 numbers and getting the GCF of it. That made sense. Like I said, I like to tell you why you're doing this. You're learning GCF so you can reduce a fraction. Okay, so 2 numbers, right? No, we're not going to mess with fractions today. 12 and 20. What's the biggest number that goes into both?
6.
6 doesn't go into 20.
4.
2 goes into both, but it's not the greatest.
4.
So it turns out that the answer is 4. Now, clearly, if I just got the right answer, some of you already know how to make greatest common factor. Others of you may be a little bit, I don't know, a little weak on this skill. I'm going to show you 2 ways of doing it. You get to choose tonight for homework. I don't care what the instructions say. You get to choose which method you want to use. Okay. There is some notation for GCF. Tonight for homework, it's going to look slightly weird. I've seen a whole lot of people not watching the board. Watch the board. Yes, I'm talking to you, Parker. This is the notation. It's going to say GCF. It's going to have an open and closed parentheses. There's going to be 2 or more numbers separated by comma or commas, if there's 3. Okay? It's asking you to find the GCF of 12 and 20. Yes? It's confusing? Is this confusing? No, right? So that's what it's going to look like tonight for homework. They're going to say, find the GCF of 12 and 20. By the way, we already found it out. The answer is,
4.
how do you write the answer?
GCF 4.
You just put an equal sign, you put 4, and you're done. Okay? Now, some of you can do this in your head, and that's fine, right? Just be careful. If you get it wrong, you get it all wrong. If you show me the procedure, right, and you make a silly mistake, I will give you some partial credit. If I ask for the GCF of 12 and 20, and you put a number that's not a factor of either, I think Abby said 2, right? 2 is a factor of both. It's not the GCF, but it is a factor. If you had said 3, then I know you don't know what you're doing, right? You say 2, well, it's a factor, just not the greatest common factor. So please, if you're worried that you won't get it right, show me all the steps. I'm going to show you 2 methods. You got to show me all the steps of either method. All right, seems pretty easy with those small numbers. When the numbers become larger, right, is when it becomes more challenging. You may want to do these steps. So there's 2 techniques. Here's the first technique. It is called brute force. In mathematics, we use the term brute force when there's a method that uses every single possibility. Right? If I ask you what is 2 plus 2 and you say, well, maybe it's 10, maybe it's 11, maybe it's 12, maybe it's 5, maybe it's 4, you're using something called brute force. You're just going to write down every single possibility and try to figure out what the answer is. Seems crazy and a lot of work. So this one requires a lot of work. The brute force technique requires more work than the other technique. It's not elegant, as we say in math. Elegant just means, oh, wow, that's pretty sweet. Right? There's no beauty involved. It's just I'm going to hammer it as hard as I can until I get to the answer. Right? It takes the most time to use brute force. Right? But it always works. Most people use brute force. Okay? Most people. It's the easiest to remember. That's why I claim that most people use it. Okay? So brute force is the method we're going to learn first, and then we will learn an elegant technique to do the same problem. I don't care which one you use tonight for homework. So this is called the brute force technique to find GCF. Lily, Josh, pay attention. All right. We're going to find the GCF of 30 and 42. Here's the method. Step number 1, you write the two numbers, 30 and 42. If there's 3 numbers, you write all 3 numbers. Okay? Step number 2, doesn't matter which number you start with. I'll start with the one here on the left, Parker. I'm going to write down every single factor of 30. Hey, that's what you did last night for homework. It said, what are the factors of 30? This was question number, I don't know, 9, something like that. What are the factors of 30?
Question number 11.
1 in, remember they happen in pairs. 1 in 15. 1 in 30, because 1 times 30 is 30.
2 and 15.
2 and 15.
3 and 10.
3 and 10.
6 and 5.
And those are all the factors. It's called brute force because I wrote down every single possibility. One of these numbers is the answer. I don't know which one. I go to 42 and I do the same thing. 1 times what is 42?
What? 42.
Okay. 2 times what is 42?
21.
What are there? Does 3 go into 42?
No.
Yes. 3 times what is 42? 13, 14? 14. 3 times 14. Does 4 go into 42? Does 5 go into 42?
No.
Does 6 go into 42?
Yes.
6 times?
7.
This is called brute force because I wrote down every single possible answer. It's not elegant, but it works every time. You look at both lists and you pick the
Greatest common factor.
the greatest number that's in both lists. What's the biggest number in both lists?
6.
So you got to write down all the factors. That's why it's called brute force. But we picked the biggest number. It's 6. Therefore, the GCF of 30 and 42 is 6. Parker, I'm still not convinced you're paying any attention. Just watch the board. It's easy to do. Okay. Ready to do one? This is called brute force. We're going to do box 2. Box 2, here we go. Big numbers. When I gave you small numbers, some of you could find the GCF in your head very quickly. When the numbers become large, they will be large tonight for homework. You got to use either this technique or technique number 2. So this is called brute force. So step number 1, on your paper, in box 2, write both numbers down. Yes? It can be. All right. We take each number individually. This is the hardest part. This is the brute force part of it. All right. Pencils should be moving in your hands. 1 times what is 54? 1 times 54. You said, could the answer be 1? The answer is yes, it could be 1. Right? That's why we got to include 1. Does 2 go into 54?
Yes.
Yay, we're using our divisibility rules. It's even. 2 times what is 54? 2 times 27. Now comes the harder part. Is 3 going to 54?
Yes.
3 times
18.
Ooh. Luckily, we got a smarty pants there to tell us the answer. This is hard, right? Because this could take some time. I'm writing down every single possibility. Does 4 go into 54?
No.
Does 5 go into 54?
No.
Does 6 go into 54?
Yes.
6 times?
9.
So the only possibility that's left are 7 and 8. And 7 or 8 go in. Notice what I did. 1, 2, 3, 4, 5, 6. These are all the things that pair with. The only 2 numbers left would be 7 and 8. Neither 7, well, 7 times 8 is not 54, right? So we're done with that. This is called brute force. I'm doing every single possibility. 72. 1 times.
72.
Oh, this is painful. 2 times.
36.
Okay. 3 times.
12.
20. 20. 20. 3 times 20.
I thought we were doing 21.
21, that would be
24.
24. Like I said, this is the challenge of the brute force. You gotta write them all down.
It's 4 and 18.
4 and
4 and 18.
okay.
6 and 12.
You still have 7, 8, 9, 10, 11. Do any of those numbers go into 72?
No.
9,
8.
8, and 9.
But it's 6. Is it 9? No, 8 and 6.
Now you look at both lists. What's the biggest number? Well, I got a 9,
18.
but I got an 18 as well. This technique will always work. It requires the most work. Brute force is tough because it requires the most work. It also requires you got to do your divisibility rules correctly, and you got to find your factor pairs. Remember, we call them factor pairs because they always happen in pairs.
Brute force would be easier with the calculator.
Well, absolutely. And if you have a calculator, I can press 2 buttons and it will tell me the answer as well. Right?
What 2 buttons would that be?
The GCF button.
GCF button?
All right. Yours doesn't have it, but mine does.
Dang
Okay.
it.
All right. Actually, what, you have a TI-30? It might have the GCF button. All right. So once again, this is called the first technique called brute force. It is the most used. This is what most people do. Now, do most people do this in their head? Yes, some do. They basically go through every single possibility and they think, wait, is that a factor of the second number? For instance, you say, is 1 a factor of 72? Yes. Is 54? No. Is 2 a factor? Yes. Is 27 a factor? No. Is 3 a factor? Yes. Is 18 a factor? Yes. And you're done. This is what the people that do in their head what they are doing. It's still brute force. Okay. All right, box 3. Let's do another one together. Here we go. Work ahead of me, please, if you can. 16 and 24. I gave you much smaller numbers so that we can do a bunch of these. 16, 24. That would be 1 times.
16.
2 times.
8.
3 times. Nothing. 4 times.
4.
And you're done. Those are all the factor pairs of 16. Now let's do 24. 1 times.
24.
2 times.
12.
3 times.
8.
4 times.
6.
And you're done. What's the biggest number in both lists?
8.
No, 8's the GCF of 16 and 24. Make sure you put your answer in the form of equals. Parker, if I walk to your paper right now, I'm going to see this written on your paper. Yes? I need you to do this. I need you to do this. If I walk on all your papers and I look, I can see Jaden's paper. She's got it written. I can see Pierce's paper. He's got it written. I can see Ace. I can see Keegan's. They got it written. You need to do this. One of the things in math is you sit in a math class, you're like, okay, that's easy. And then all of a sudden the bell rings and you're off to your next class and you forget everything. And you get to the test and it says GCF, you're like, I don't know what to do. Because you didn't practice it. Make sure you're doing this. Are we good on the first technique called brute force? It's an easy technique. It's also easy to remember. I highly recommend on Thursday when we do the review that on your resource card, you have at least 1 example. You don't need more than 1 to remember this. Okay? One more time. 15 and 28. 15 and 28. Here we go. 15. What are the factors?
1 and 15.
1 and 15.
3 and 5.
Anything else?
No.
Okay. 28. What are the factors?
1 and 28. 2 and 14. 4
Oh,
and
a
7.
little bit slower.
4 and 7.
4 and
7.
Lily, question?
So we're gonna remember have only a
Well, let's
one
see.
greatest common factor. Only like
I got 1, 15, 3, and 5. I got, well, the only number they have in common is?
1.
So, yes. We have a name in math when 2 numbers, or 3 or 4 numbers, only have 1 in common. You ready? Next box, why it's blank, right? This will be box 5.
close.
Write this down. We call 2 numbers where the only common factor is 1. We call them? We do, except neither one of these is a prime number. So we can't call the numbers prime.
GCF.
It would be close. We're going to call this relatively prime. When 2 numbers only have a GCF of 1, We call the 2 numbers or 3 numbers or 4 numbers, we call them relatively prime. Remember, we call prime number, Parker, move the pencil. I got to get that box.
What box?
I told you, didn't I tell you the other class?
No.
So Mr. Calinello 2 years ago stole my idea. That's why I don't talk to him much anymore, because he steals my ideas.
That doesn't sound right.
This was a teacher idea. I said I should get the,
All the divider boxes that go on.
No,
like
the
this.
box where you press the button and it makes a sound effect. And I said, I told him 2 years
the
ago,
sound box.
I was like, I want to get one of these. So there was like, there's applause, there's
soundboard.
boos, there's Parker, move your pencil, right? There's all right, quiet class, right? And, I told him that 2 years ago. He goes, I got one of those boxes. And he stole my idea.
He didn't steal it. He already had it.
I know, but he didn't think of that to bring to his
He
classroom.
used it for Jeopardy and sound effects.
Yeah. He only uses it for Jeopardy.
I know.
That's my favorite.
But this is my idea.
But he already had.
He had the box, but he didn't think to bring it to his
This
classroom.
is right, I have an idea.
Conversations that we
You can. Why don't you just get one, or you go in there and you steal his and you bring it in here.
No,
That's messed up.
I had this thought probably about 10 years ago, but I just I've been too lazy.
Say
Yo,
you're
I'm
borrowing
a
it, but never
play.
give it back.
What's up?
Miss Packard last year, she had like.
She had one too?
A doorbell sound effect.
Ah.
So whenever we were way too loud, she would like spam the doorbell really loud. Ding, 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 ding.
All right, so we just found out the GCF of 15 and 28 is 1, therefore 15 and 28 are relatively prime. Tonight for homework, they may ask, are these 2 numbers relatively prime?
No.
All they're asking is the GCF of the 2 numbers 1?
Yes.
If it's any other number other than 1, then the answer is no. Okay? All right, on your own, here are 2 examples, 28, 42, and 56 and
Well, we just
84.
did
On
28.
your own, find the GCF. You just did 28, but you didn't do 28 and 42.
I don't need a GCF button.
What?
I don't need a GCF button.
Let me see your calculator. Now, and while you're working, I will confirm. Oh, anyone need help? Yes.
If you would just say both have 2, it would be on there. No.
Oh, no, we're not asking are they relatively prime. I'm asking find the GCF. But you are correct on your thought.
How do you get to it?
Well, I'm trying to put. I'm not sure if this one does.
Okay, so I pushed the wrong button.
You didn't press all of them.
Did you press the power on and off button?
There's some hidden buttons that you don't know about.
Really?
With the second
Yeah, you have to hit second and then there's more buttons.
You got that right.
Oh,
I
so
bet
like
that'll
new
lower
buttons
the
pop out of a calculator?
It does not appear that this has GCF.
Darn it. All right, I guess
Then
I'm going
you
to
press the
sorry.
second part.
Yeah, I need it.
But do you want to
All
know
right.
something?
We good? Anybody need help?
I hate brute force.
Brute force it's not very elegant. It's not very elegant. But it is effective. Lily, you good?
I'm just like on the homework right now, and I'm realizing that's the problem that I'm stuck on. What are the A, B, C, D, and E's? A, B, C.
It's so variables that you want to have those letters.
No.
No.
All right, let's work, please. Let's work.
Mr. Chartier,
I'm listening.
you know how you can play like Tetris and stuff on your calculator?
I don't have Tetris, no.
Wait, you can play Tetris?
I love playing.
I don't have
Snake
Tetris.
I love playing
Oh, man,
Snake
I
on
love
it.
Tetris.
Well, I was at work with my dad on Monday.
Who's the last one?
What?
Part team. And we were sitting there on the drill rig, and one of his guys is like, "Oh, look at this! You can play Tetris on here." And his boss walks out and he says, "If I ever get you playing Tetris on there, you're fine."
Yeah, exactly. All right, we ready? We got them both done?
No.
All right.
I got one of them done.
I got one too. I got one.
This is horrible. not that bad.
Wait, let's see.
Pretty bad, but it's not that bad.
It's not that bad. It's not.
Saying it's
One.
not that bad means it's still
You
bad.
just get
but
one
not
done, you
that
get
bad.
two
Not
done.
bad, but it's not bad.
You're
laughing.
One, two, one, two, one, two, one.
Just divide both numbers by 2. The first number would be, and the second number would be divided by 2. 1. Yeah. All right, here we go. Let's see. GCF of 2842. So the factors of 2842 are 128, 2 and 14, 4 and 7, and that's it. 42 has 1 and 4. What I generally do, for me, if I'm doing brute force, is I only do the first one. Why? Like I don't even write the factors of the second. Why do I only do the first one? Because one of these numbers is the answer. So I don't need to write the second one. I just need to write the first one and then ask, does 1 go into 42?
No.
And actually, if you're really smart, you don't start with 1. You start with the largest number and then go down from that. Because whatever answer is yes will be the answer. Does 28 go into 42?
No.
Does 14 go into 42?
Yes.
I mean, that's the one that's hard, though. I mean, like, you might not be able to count by 14s. What turns out it is, if you can't remember that, well, then you write down, this is the brute force method, you write down all the factors. When I write down all the factors, we find out the answer is 14. But if you want to use the semi-brute force method, which is you just write the factors of the smallest number, that would be technically the easiest one to do, and then you look at all the answers, and one of these numbers is the answer, right? 7 goes into 42 as well, too, but so does 14, okay? Does that make sense? All right, well, let's see that technique with larger numbers. 56 and 84, by the way, 14 is the answer. 56 would be what? 1 and 56, 2 and 28.
4 and 14 and 8 and 7.
And
Well,
7
I
times
said
8.
eight.
All right. Highest one. Is 56 going 84?
Yes.
No.
Oh, no, sorry.
Does,
Well, like, goes
does
into
28
it.
go into 84?
Yeah.
Well, how many times?
3.
3, right? This is the hard. I mean, I'm going to say some of you might be able to do this. Most of us would look at 28 and like, well, I don't know if it goes into 84 or not. It turns out that it does. But you would not realize that unless you actually did the second thing, which is.
We don't like brute force.
Well, it's called brute force for a method. Brute force means you're going through every single possibility. So it turns out 28 is the answer. Are we okay with brute force?
No.
All right.
I know how to do it. I just don't like
Okay, well, I'm going to show you the second technique. If you really, truly like it, that's great. I'll just say this. What typically happens is that I'll teach the second technique. I'll have lots of people say, oh, that was easier. They'll like it. But a year from now, when I say, hey, reduce this fraction, none of you will be using this technique to do it. You'll be using brute force. Like I said, it's because it's not the most memorable technique. All right, next technique is not called brute force. It's called, hey, what you did for homework 2 nights ago, prime factorization. You did it last night as well, too. So this is called the prime factorization. And I'm going to argue the reason why this one is forgettable is because this same technique, prime factorization, is also used for LCM, least common multiple, except it's different. And that's why it gets confusing. Brute force is not confusing. It's easy, but it takes a long time. The second technique, prime factorization, it takes a little bit less time. It also it's elegant. It's nice, it's sweet, right? It's just a little bit easier, right? Maybe if it takes you a minute to do brute force, this will take you 40 seconds to do, right? It still takes time. It always works, just like the previous one. It's the hardest one to remember, and you'll see why when I give you tomorrow's class, because you'll confuse this technique with the one that I show you tomorrow, which is why it's not used very often. Like I said, 2 years from now, none of you will be using prime factorization to reduce a fraction. But some of you might look at this one I'm about to show you and say, wow, that's nice, I like it. That's fine, right? No harm in using it. Just realize that I bet you in 2 years you don't remember how to do this. All right, prime factorization, GCF. Here's how it works. same two numbers. We already know the answer because we already did this one, 30 and 42. Here's how it works. We take each number by themselves, and we do the prime factorization. Give me two numbers that go into 30.
3 and 10.
Okay, I'm not sure what I chose, but I chose 2 and 15. But I could choose 3 and 10. We do the prime factorization, right? I'm getting really lazy. I'm not drawing the little caret, right? I do the prime factorization, right? So what's the prime factorization of 30?
2 times 3 times 5.
2 times 3 times 5. Okay? We do the same thing for 42. I'm lazy. I'm going to use 2. So 2 and 21, 2's prime, 3 and 7. Are you paying attention? Jaden's not. Okay? 3 times 7 is 21. So the prime factorization of 42 is?
2 times 3.
The reason, now this seems like a little bit less work. The reason why this is forgettable is because of the next step. By the way, tomorrow, the technique for using this is exactly the same up to this point. It's what you do next that's forgettable. For GCF, greatest, the middle word is, I pick only what's in common between the two prime factorizations. I'm only going to pick what's in common. This one has a 2. How many 2's does it have?
1.
Does this one have a 2?
Yes.
So it's common, I use a 2. This one has a 3. How many 3's?
1.
Does this one have a 3? So it's common. So I'm going to use the 2 and the 3 because they're common. This one has a 5. Does this one have a 5? So I don't use it. This one has a 7. Does this one have a 7? So the only thing these two have in common are, well, what's 2 times 3? So therefore the GCF is.
Oh, that's easy.
It is,
That is
and it's
10 times easier.
it's elegant. It's just forgettable. Okay.
I have a question.
Yes.
So say that it gives 3 of the same numbers.
We're going to do that next. All right. So let's do one. Here we go.
It doesn't matter what order you do it in.
Doesn't matter what order you do it. Okay. But what she wanted to bring up is the one will happen for this one. Okay. So here we go. GCF of 50. We've already done this. 54 and 72. So we start with 54. That's
1 and 54.
no, because
2
that
and
does,
27.
how about 2 and 27? Okay. So 2 and 27. 2's prime. 27.
3 times 9.
3 times 9. 3 is prime. 9.
3 times
3 times 3. Okay. So the prime factorization of 54 is,
2 times 3 to the 3rd power.
or 2 times 3 times 3 times 3. Okay. 72. That would be.
6. No. 9 times 8.
Okay. I'm going to do 2 times 36. But 9 times 8 works, right? 2's prime. 36 is,
6 times 6. 3 and 12.
or 2 and 18. Yours fine. Continue on your method. That's fine. 18 is,
9 times 9.
and 9 is 3 times 3. So the prime factorization is 2 times 2 times 2 times 3 times 3.
So
Notice I'm not writing them in exponential form. I can. We need to find, this is Bree's question, common. Hey, how many 2's does this one have?
1.
How many 2's does this one?
2, 3.
So if we only choose what they have in common, what do they have in common for 2's?
2 3s and 1.
For 2's.
Oh, they have 2s.
They have 1 2 in common, right? If this one had 2 2's, then we would say 2 2's, right? This one has 3 2's. So the only thing they have in common is 1 2. So I need a 2. Hey, how many 3's?
3.
How many 3's? So how many do they have in common?
18. 18.
2. So I need 1 2 and how many 3's do I need? 1 2 and 3. Only what they have in common. What do they have in common? 1 2.
18.
This one has 1, but this one had 3. So common would only be one of them. This one has 2 3's. This one has 2 3's. So they have 2 3's in common.
2 times
So 2 times 3 is
6.
times 3.
18.
The answer is 18. It is elegant. It is sweet. It's nice. Is it memorable? Today it is. Tomorrow, the last rule changes for LCM. And that's why it becomes confusing for students, which is why it's not memorable. It's memorable for the test because you can write it on a resource card.
Do we have to use factorization?
I said for homework, you may use either one. Don't care.
On the test.
Either one. Do not care.
Okay.
I need you to find the GCF. All right. Hardest to remember. You're like, that's not hard to remember. Yeah, because it's the only thing. Wait till tomorrow. Right? It's the least used. Nobody, no high school student uses this. I have a big argument with, I mean, this is actually taught, should have been taught to you last year, by the way.
Oh, it is.
All right.
No.
But it's usually taught somewhere between the 5th and the 6th grade. And by 7th grade, yeah, we still teach it. It's a cool, nifty trick. Nobody uses it in high school. I say reduce the fraction. I see no one doing prime factorization. They just say, divide it by 3. Right? Okay. Once again, box 6. See if you can beat me to the answer. So I'm going to do 16 to 20. No. Make sure you use the prime factorization method.
Box 6.
Oh, is it box 8? Sorry.
Is it box 8?
So 16, let's see, that would be 2 and 8. 2's prime. 8 is 2 times 4. 2's prime. And 4 is 2 times 2. Where's my box? He knows what I'm saying. So I got a whole bunch of 2's. I got 4 2's. That's the prime factorization. 24. 2 times 12. 2's prime. 2 times 6. 2 is prime. 2 and 3 for 6. Both of those are prime. So I have 2 times 2 times 2 times 3. I got 3 2's and a 3. Hey, is 3 in both numbers?
No.
I don't need it. I got 3 2's and I got 4 2's. What do they have in common?
2.
3 2's. Therefore, the answer must be whatever 2 times 2 times 2 is. Is everyone tracking?
It's 6.
It is not 6.
I know.
2 times 2 is?
8.
2 times 2 is?
4 times 2 is 8.
I know. Times 2 is 8. So the GCF is 8. Prime factorization. Hey, the last step is the only thing we got to make sure. I mean, I know some kids are definitely got this, but maybe there's a few of you that don't. Do you understand why I only use 3 2's instead of 4 2's? Right? Hey, there's 4 2's here, but there's only 3 2's here. You only choose what they have in common. Okay? Yes? All right. Box 9, beat me to the answer. Let's see. 15. Prime factorization would be what's 3 times 5. Those are both prime. Okay. 28 would be 2 and 14. 2 and 7. Those are both prime. And you notice the list, they have nothing in common.
But just 1.
Therefore, remember, all numbers have 1 in common. We just choose not to write the 1. Right? Because if you put times 1, nothing really changes, although 1 is a factor of it. Okay? All right, so we get the fact that these are relatively prime. Remember the definition, relatively prime? When the only number they have in common is 1. So once again, 15, 28 are relatively prime. Relatively prime. Questions?
No.
All right. This is the last one?
Yeah.
Last one.
Yay.
Use prime factorization. Right, even though this is literally the same box that you already did before. All right, 28, 42. Let's see, 28, 42. So 28 would be 2 and 14. 2 and 7. So 2 times 2 times 7. 42 would be 2 and 21. 2's prime. 21 would be 3 and 7. So we get 2 times 3 times 7. There's my list. What do they have in common?
2.
They got 1, 2, and a 7. So therefore, it's 2 times 7, which is 14 is a GCF. Let's do the last one. We're almost done. GCF is 14. We okay? Josh, good? Lily? Okay. All right. 56 and 84. 56 and 84. That's 2. I always go, if it's even, I'm just going to pick 2. 2 times 28, 2 times 14, and 2 times, so 2 times 2 times 2 times 7, prime factorization.
2 times 2 times 2 times
84 is a big number, but prime factorization makes it a little bit easier. 2 times 42. 42 would be 2 times 21. 21 is 3 times 7. 2 times 2 times 3 times 7. This one has 2 2's. This one has 3 2's. So the common is 2 2's. No 3s in common, but 1 7. So 2 2s and a 7. 2 2s and a 7. 2 times 2 is 4. Times 7 is. Tonight for homework, you can pick. You want to use brute force, great. If you want to use prime factorization, great. I don't care. Ignore what the instructions say. Last thing is this. What? You forgot your 3. Okay. Last thing is this, right? Obviously, some kids will like either one. It doesn't matter. If you have to do it with 3 numbers, I thought I had 3 numbers. I guess I didn't. Never mind. I thought I did one with 3, but apparently I didn't. You can do this with 3, just to repeat the process. All right, grab your books. Get started on your homework, please.
Okay.
We got 10 minutes.
10 minutes. Can I go to my locker to grab my binder? So,
Parker.
Or 10 minutes.
what did I do? No.
What? Yeah. What?
Abby.
When he comes back.
Abby. No. Sorry.
All right, let's go. Math books out. Get started. All right, e-learners. Any questions, Elizabeth or Malachi?
I wish both.
Elizabeth or Malachi? Questions?
No.
Malachi? Anything? All right, cool. You feeling okay, Malachi? No? Don't know? Drink water. I don't know. That's what they always told us in the Army was drink water.
Drink water. Don't drink water.
Right. All right, I'm going to end the video right now. If you guys have any questions, send me a chat or email.